Alright then, year 6, so you should have had a go at that arithmetic test and marked it. Now, I picked out 8 questions that might have maybe muddled a couple of people. So I just thought I would go through these 8 questions for you and see if you got it wrong, then you can see where you went wrong, and hopefully for next time that will help you correct your errors. So we'll look at question 4, 13, 14, 15, and then on the next page we'll do 17, 23, 30 and 34. Obviously there might be some other questions that you got incorrect, and if you're not sure why, you could always email your teacher and we will talk it through with you. So looking at number 4 first of all, it's a missing number problem. Now sometimes these confuse people about what operation you need to do. So it's a number subtract 33 equals 34. Now you might look at these and think, oh well, it's 34 and 33, so that needs to be a 1. Whereas if you think about that question, that'd be incorrect. 1 subtract 33 is 34. Clearly not right. So this number here has to be the largest number out of the 3 numbers that are in this calculation. So the way to do this is to do the inverse. Even though it's subtraction, we need to add these numbers up. So 34 and 33, and then if we add those up to get to 67, right then, does that look like a sensible answer? 67 subtract 33 is 34. That's where your answer is 67. Right, looking at number 13 now. We looked at one of these questions last week again, but because there are a few steps involved, there are quite a few areas for you to go incorrect, so we thought we'd go through it again. So when you do any subtraction or any addition involving fractions, even though this is a mixed number fraction, the denominators need to be the same. And you can see here, this is 3, this is 5, so they're clearly not the same. So what we need to do is we need to try to make them the same. So if we ignore the whole numbers now and just concentrate on the fractions, we've got 3 and 5. So we need to find the lowest common denominator, the lowest number that is both in the 3 times tables and the 5 times tables. And hopefully you've realised that it's 15, because if you do your 3 times tables, if we do 3, 6, 9, 12, 15, do your 5 times tables, 5, 10, 15, 15 is the lowest one. So we are turning both these fractions into the denominator of 15. They're still going to be equivalent fractions, still going to be the same size, but we change the denominator to 15. So because I've just done my 3 times tables, I know that 3 times 5 is 15, so I need to do the same to the numerator. So 1 times 5 is 5. I had to times that by 3, so I need to do the same to the numerator. Here we go. And now I can write in the whole numbers. Now, because this fraction is larger than this fraction, because the 5 is larger than the 3, what I could do at this point is I could just subtract the whole numbers and then subtract the fractions. So I will do that because it's the most straightforward way of doing this. So 7 subtract 2 is 5, and then 5 subtract 3 is 2. The denominator stays the same. So the answer to this one will be 5 and 2/15, and this one can't be simplified. So moving on to number 14 now. It's division. It's division by 2 numbers. So if you got this one right, this would have been worth 2 marks, just like number 15 would have been worth 2 marks. Now, we've looked at the 2 different ways you could do this. You could do this by writing out your 17 times tables, and you could do this in the factor method. Hopefully you've all realised that you actually can't do the factor method with this, because 17 is a prime number. The only numbers that you can divide 17 by are 17 and 1. So there are no other factors of 17. So the factor method, where you think of 2 numbers and then you divide it by one number and then you divide it by the other number underneath, you can't do that with this number because 17 is a prime number. So doing that, you have to work out your 17 times tables. Now, probably the best way of doing this is to add your 10 on first and then add the 7 on at the end of that. Or you could add 20 on and then subtract 3. It's very difficult to be trying to work out what 17 is added on. So if we add 10 on, and then if we add another 7 onto this, go on to 27, then add the 7 on, takes us to 34. Do the same again, add 10 onto this to get to 44, add the 7 to get to 51. Now, because I've seen there's a 51 there, we could carry on with our 17s, but looking at this, with the 51 there and this 51 there, it's probably a good idea to stop. We don't have to do extra work for ourselves. So how many times does 17 go into 5? It doesn't. The 5 gets carried over. How many times does 17 go into 51? Well, we can see 1, 2, 3. How many times does 17 go into 0? It doesn't. 30. So you got 2 marks for that, and really, I think that's quite a straightforward 2 marks. I think that you only had to figure out an extra 2 in your 17 times tables. So 30 was the answer. Right, looking at number 15. Now 24, there are an awful lot of factors for 24. You could just write out your 24 times tables if you wished. You could have done 2 times 12, you could have done 3 and 8, you could have done 4 and 6. Lots and lots of different ways you can do this. I'm going to do 4 and 6. The reason why I've done that is I can see here that there's an 8 and there's a 16 in there. So it's going to be quite straightforward to do that. So I'm going to use 4 and 6 because we times 4 and 6 together to get to 24. So how many times does 4 go into 8? Twice. How many times does 4 go into 1? Doesn't. How many times does 4 go into 16? 4 times. So this comes down here. 204 divided by the other factor. How many times does 6 go into 2? It doesn't. Gets carried over. How many times does 6 go into 20? 6, 12, 18. 3 times with 2 left. How many times does 6 go into 24? It goes in 4 times. So the answer to number 15 is 34. And again, that's a 2 mark question. Right, so if we look at these 4 questions now. So 17, it's a multiplication, but it's with a decimal in, and sometimes it confuses people. Now remember, the decimal just needs to be lined up, so I could put it in before I've even calculated it, just directly underneath. So there's going to be a number here after the decimal point, and the rest of the numbers are going to be there. And it's really very, very similar to if that was the question there, 854 times 4. The answer would be the same, except this has got a decimal place in, so the decimal point needs to be lined up. So we just approach it as a normal multiplication. So 4 times 4 is 16, so the 6 goes there, the 1 over in the next column. 4 times 5 is 20, add 1 is 21. And then if we do 4 times 8 is 32, add the 2 is 34. So 341.6 is the answer for that one. 23, 25% times 540. Remembering that this question is quite similar to that one with that of. It's that what is 25% of 540. So to do this, we did this last week, remembering that percentage is out of 100. There are 25. How many 25s are there in 100? 25, 50, 75, 100. There are 4. So we need to divide this number by 4. How many 4s go into 5? 1 with 1 left. How many 4s go into 14? 4, 8, 12. Can't go further than that, so it's 3 with 2 left. How many 4s go into 20? It is 5. So 25% times, or 25% of 540 is 135. 135 is the same as a quarter of that. Looking at number 30 now. What is a fifth of 40? So 40 is going to be split between 5, and what is 1/5 of those? So it is basically how many 5s go into 40. So you could do it as a division, or you could think about just your times tables knowledge. Something times 5 is 40, and hopefully you got to the answer of 8. Right, number 34, this is a missing number one. And it's similar to this one, but sometimes with the missing number ones, people get a bit confused about how to approach it. So 1/10 of a number is 8. So 1/10 of a number is 8. So I'm looking really for what the whole is, aren't I? For what 10/10ths are, or 1 whole of the number is, to find out if that 8 is just a 10th. So the way to work that out would simply be just to do 10 times by 8, which is 80. And you can see if you write it in there, 1/10 of 80 is 8. It makes sense, doesn't it? So that's how we got to the answer for that one, year 6. Okay, I hope you all have a really, really lovely weekend.